Learning Objective 10 from Section 4.2 is to interpret output from a statistical program and/or calculator to carry out a hypothesis test. We're going to do this using GeoGebra output. A consumer agency is interested in testing whether a particular manufacturer's claim of a mean lifetime of 220,000 miles for its car engines is accurate. GeoGebra was used to perform a hypothesis test, and the results are given below. Using a significance level of 0.05, which of the following is the correct conclusion? The GeoGebra output shows us several things. You can see the null hypothesis is mu equals 220,000. Let's write the alternative hypothesis. It is that the mean lifetime of these car engines is less than, because we see that less than bubble shaded in, our claimed value, which is 220,000. We also can see down here below the p-value, which is given as 0.0247. That is less than our alpha level of 0.05 given above. So therefore, since our p-value is lower than our alpha, we will reject the null hypothesis, and we will say that there is sufficient evidence to conclude that this alternative hypothesis we've written is correct. So let's look at these conclusions. We already know that there is going to be sufficient evidence to conclude the alternative hypothesis is true, so we can eliminate answers C and D. A says there's sufficient evidence to reject the null hypothesis and conclude that the mean lifetime of car engines of this type is 220,000 miles. That's saying that there's sufficient evidence to conclude that the null hypothesis is true, which is never a correct conclusion. We're always determining whether or not there's sufficient evidence to conclude that the alternative hypothesis is true. When we're talking about the null hypothesis, we're stating whether or not we reject or fail to reject it. So let's look at answer B. There is sufficient evidence to reject the null hypothesis and conclude that the mean lifetime of car engines of this type is below 220,000 miles. That is the correct conclusion.